Hello everyone, welcome to my YouTube channel, and this is X. So in today's video, we'll be looking at evaluation of limits by simplification. There are several methods of evaluating a limit. The very first is limit by substitution, where you just have to input in the value for which the limit approaches, right? And after that is by simplification. And by simplification, we mean either by factorization or by rationalization, right? And sometimes these methods may fail. There are some functions you cannot be able to simplify, you cannot be able to evaluate. There are some limits you will not be able to evaluate by simplification, and so we have to resort to the L'Hopital rule and then move over to discrete theorem, right? So today we want to see those functions, those limits that we could actually use the method of simplification and how it actually works, right? So when our limit by substitution fails us, the next thing we resort to is by simplification, right? So we want to see how we are going to be able to simplify this. So the first question says that the limit as x approaches 0 for x minus root x divided by root x. So for this question, if we substitute x for 0, this is 0 minus 0 divided by 0. So 0 minus 0 is 0, all divided by 0. And that's an indeterminate. You don't want to divide by 0, right? So that's why we are going to be rationalizing. Why are we rationalizing instead of factorizing? We are going to be rationalizing because of the radicand signs, the roots, the square roots that we have here. That's the reason why we are rationalizing instead of factorizing, right? So let's rationalize this question. We are going to be rationalizing by multiplying by the conjugates, right? So this is x plus root x all over x plus root x, right? So expanding will give us our limit as x approaches 0. X times x is x squared. X times square root of x is plus x root x. Root x times x minus x root x. Root x times root x will give us minus x squared. Minus x rather. Minus x, yes. Divided by root x times x is x root x. Root x times root x is x, right? So simplifying, x squared, okay, root x plus root x minus x root x gives us 0. So we are left with our limit as x tends to 0, x squared minus x, because this is 0, right? X root x plus x. Is that true? At this point, we can factorize because our x are common. So we have this to be x into, here will become x minus 1, right? Divided by, here will be x root x plus 1, right? And this can cancel out with this. So we are left with limit as x approaches 0 for x minus 1 divided by root x plus 1. And so by substitution, we can substitute this point now. 0 minus 1 is minus 1. 0 plus 1 is 1. So this is equal to minus 1. So the limit of our function as x approaches 0, by simplification, we'll be able to find it to be 1. Right? So we can go over to solving the next question. Solving the next question, we have limit as x approaches infinity, this time around is infinity, square root of x multiplied with x minus 3, root of x minus 3 minus root x, right? Okay, so we see if we substitute, we cannot substitute infinity into this whole thing. It's something that is going to blow up for us. So we are going to simplify it by rationalization, right? If we multiply here by expanding, we'll get limit as x approaches infinity, root x times root x minus 3. By law, by law of sorts, we are going to get x squared minus 3x, right? Minus root x times root x minus x. Okay, so at this point we can go on to rationalize, and that's by multiplying by the conjugate, right? Multiplying by the conjugate of this thing. Minus 3x minus x being multiplied with x squared minus 3x plus x divided by x squared minus 3x plus x, right? So by expanding that, x squared minus 3x multiplied by x squared minus 3x with their roots will just give us x squared minus 3x, because you agree with me that root 2 times root 2 will be equal to 2, right? So if we are multiplying this, it will just be just same thing. And then the root of x squared minus 3x multiplied by x to give us plus x squared minus 3x, right? Then we have minus x multiplied by this minus x squared minus 3x, right? And minus x times x, this is minus x squared minus x squared. Okay, divide through by x squared minus 3x plus x, and our limit still remains that x approaches infinity, right? So x root x squared minus 3x minus this should give us 0, right? So we are left with the limit as x approaches infinity, x squared minus 3x minus x squared all over x squared minus 3x plus x, right? That's what we are left with. Okay, so what else? X squared minus x gives us 0, so we are left with the limit as x approaches infinity, right? Minus 3x all over root x squared minus 3x plus x. Should that be what we will have, or there is a mistake somewhere? No, I don't think so. I don't think there's any mistake somewhere. So we can still rationalize the denominator, right? We can still rationalize the denominator, and I hope we wouldn't go back to where we are coming from. Wow. Question number 3. The limit as x approaches 2 for x squared minus 4 all over x minus 2. Okay, so you can see that we cannot substitute x for 2, although x approaches 2, because 2 minus 2 is 0, and we don't want to divide by 0, right? And if you look at this particular question, it does not have a radicand, no roots, right? So we can simply go ahead and factorize. Okay, so this is the limit as x approaches infinity. Factorizing x squared minus 4, that's difference of 2 squared. So we have x minus 2, x plus 4 divided by x minus 2, right? So x minus 2 will cancel x minus 2, right? And then we have limit as x approaches 2 for x plus 2, which is equal to 2 plus 2, and that's 4, right? So we move on to the last question, and the last question says the limit as x approaches 2, we have x squared, the quadratic x squared minus 3x plus 5, okay, plus 2 divide through by x squared minus 2x, right? Okay, so for this, although x approaches 2, 2 squared is 4, 2 times 2 is 4, so 4 minus 4 is 0, and we don't want to also do that, we don't want to divide by 0, right? So we can actually factorize. To factorize x squared minus 3x plus 2, we are going to have x minus 1, x minus 2, right? Looking for two numbers such that if you multiply them, they will give you 2, and if you add them, they will give you minus 3. And the numbers are minus 1 and minus 2, right? Divided by, here we can factorize x minus 2, right? So this and this cancels out. So we are left with the limit as x approaches 2, x minus 1 all over x, right? So 2 minus 1 is 1, so this is equal to 1 all over 2. So this has been a beautiful journey. If you find this video interesting, like, subscribe and share to your friends. Thank you.